Good evening once again. My name is Arnold Young and this is Single Variable Calculus lecture series. We are still on limit and today I bring you the second part of the tutorials we started on limit. So I also want us to solve some problems today. They are interesting ones, so let us begin. So the first one will be, we are starting simple. The limit as x approaches 0 of x over root of x minus, 4 minus x minus 2. Now, I've already told you, but then first let's check if it's an indeterminate before I continue what I was saying. So doing our direct substitution, we end up with 0 over root of 4 minus 0 minus 2. End up with 0 on 2 minus 2. Get 0 over 0. So clearly this is an indeterminate. And if it's an indeterminate, I've already said that is if the numerator or the denominator contains a radical. Try as much as possible to do what? To eradicate the radical by rationalizing or substituting in some expression to cancel out the radical. And it is simple. So we can use two methods. I've already talked about this. So the method 1 will be our normal rationalization. So the limit as x approaches 0 of x over root of 4 minus x minus 2, multiplying both the numerator and the denominator by the conjugate pair of this expression. So root of 4 minus x plus 2 divided by root of 4 minus x, that is plus 2 as well. Now the product of these is basically the difference of two squares. Then I can write this as the limit as x is approaching 0 of x multiplying root of 4 minus x plus 2 in parentheses divided by, as I said, these can be written as difference of two squares. So I have, that's 4 minus x, the root of this all squared, minus 2 squared. So I can have the limit as x approaching 0 of x multiplying root of 4 minus x plus 2 in parentheses divided by 4 minus x minus 4. Now what do I end up with? The limit as x approaches 0 of x multiplying root of 4 minus x plus 2 divided by, that is negative x. I end up with the limit as x approaching 0 of, that is negative 1, multiplying root of 4 minus x plus 2. So from here, I can do my direct substitution. So as x is approaching 0, what do I get? I end up with negative root of 4 minus 0 plus 2. So I end up with negative 2 plus 2, and my answer is negative 4. As I said, you can also substitute in some expression. That one will be lengthy, but you can try that one. You can substitute in, say, it was limit as x approaching 0 of x divided by root of 4 minus x minus, so I can say let's say t be equal to, that is t squared be equal to 4 minus x. So in place of 4 minus x, you substitute in t squared to cancel out the square root here. Then you proceed. So let's do it. So the limit as x is approaching 0. Now our limit is also changed, mind you. So as x approaches 0, what will be our t? So here t squared is equal to 4 minus 0. So our t will be plus or minus 2, but we'll take the positive root as I said. We are not talking about, that is one-sided limit. So what are we going to end up with? Now, what will x be for here? X will be 4 minus t squared. X will be 4 minus t squared. The limit is as t approaches 2. Now, as I said, this will be what? This will be t, because when I substitute in t squared here, the square will cancel out the root sign. Then we end up with this. So from here, I can factorize the numerator, write it at difference of two squares. I get 2 plus t multiplying 2 minus t. Now the work is done. It is simple here. What can I do? I can factorize out negative 1 from this expression. Then I end up with the limit as x approaching 2 of, that is negative 1 t minus 2 t plus 2. What am I going to get? What am I going to get? What am I going to get? My t minus 2 cancels out this t minus 2, so I end up with negative. So as the limit as t approaches 2, what will be my answer? My answer will be, that is 2 plus 2, the negative of this. Then I end up with negative 4. This is quite understandable. Let us move on quickly to the next problem. Now, this is a bit technical. I'm just wishing most of you guys have seen such problem like this, but no worry, no problem, you will understand. So 256 x divided by 256 x to the power 4 plus 81 x to the power 2 plus 49 all raised to the power 1 over 4 is equal to 1 over a. The question is find a. Find a. So it is simple. Let us find a. Now, we first evaluate the limit on the left-hand side of the equation. So let us do that. Now, since you are taking the limit as x approaches infinity, what can I do? As I said, I can factorize for the numerator. I have a single term over here, which is x. So I don't have any problem here. But for the denominator, I can factorize out some expression, right, such that when that particular expression is factorized out, it will cancel out the expression on the numerator. So what will I end up with? The limit as x is approaching infinity of x divided by, now for here, can factorize out here x to the power 4. What do I get? 256 plus 81 on x squared plus 49 on x to the power 4, 1 over 4. Now, the 1 over 4 affects every single term here. It affects every single term here. So it will affect this parenthesis. It will also affect this. So I can rewrite this as the limit as x is approaching infinity of x divided by x to the power 4 raised to the power 1 over 4 multiplying 256 plus 81 on x squared plus 49 on x to the power 4 raised to the power 1 over 4. So from here, x to the power 4 raised to the power 1 over 4 is x. So this term cancels out this term. So what do I have left? The limit as x raised to the power infinity of 1 over 256 plus 81 on x squared plus 49 on x squared all raised to the power 1 over 4. Now, I've already said this in the previous lecture, as x is approaching infinity, 81 over x squared will approach 0 because I have 81 divided by, that is infinity squared, a large value squared, and this whole term would approach 0. The same thing, 49 on x squared will also approach 0. So what then will be the limit value? My limit value will be, let me write it somewhere here. That is, as x is approaching infinity, I'll have 1 over 256 plus 0 plus 0 all raised to the power 1 over 4. Now, 256 raised to the power 1 over 4 is what? 250 raised to the power 1 over 4 is what? Now, 256 raised to the power 1 over 4. I'm writing somewhere here. So 1 over 256 raised to the power. So you are taking the fourth root of 256. What would the answer be? Taking the fourth root of 256, what would the answer be? Now, we know one specific thing. We know that is let me say I'm coming 16 by 16, 36, 616, 9166, 111. We end up with 6 is 15, 2. So the square root of 256 is basically 16. Then I can say that the fourth root will definitely be 4. So the fourth root of 256 is 4. So we end up with 1 over 4. We end up with 1 over 4. Yeah, I've actually forgotten my arithmetic a bit. I don't normally keep the fourth root of certain values in my head and the square root of certain values in my head. So I'm sorry if I delayed, but then we've achieved what we want to achieve at the end of the day. Okay, let us move on to the next question. Let's move on to the next question. The questions are getting interesting. Now let's solve one beautiful question. Now say you have the limit as x is approaching 1 of the expression x squared minus root of x divided by root of x. So for here, you do your direct substitution. So we are checking if it's an indeterminate. So we have 1 squared minus root of 1 divided by root of 1 minus 1. End up with 0 over 0. And if you have 0 over 0, then what do? Since both numerator and denominator contain a set, then we rationalize or we try as much as possible to get rid of the set. So we can first try the substitution method. Now I'm substituting in some particular variable such that the radical will go away. So I can say let say y squared be equal to x. And if y squared is equal to x, then what will y be if x is approaching 1? So as x approaches 1, our y will be what? Our y will also be 1. We are taking the positive root. Since you are not doing one-sided limit, one-sided limit, you are just taking the positive root. So y will also be what? 1. Then I can say the limit as y approaches 1 of, now what will be x squared? X squared will be y to the power 4 minus, now if I substitute in y squared into the square root, what am I going to get? I'll end up with y here. Here, what will I get? I'll end up with y minus 1. It is that simple. Now from here, the job is done. I can do my factorization. Y out, y cubed minus 1 divided by y minus 1. Why? Because y is a common term, right? Y is common in both terms. So I can factorize out y. But then y cubed minus 1 can also be factorized using difference of 2 cubes. I already know that if you have a cubed minus b cubed, it can be written as, if you remember, I said this, and even from high school algebra, it can be written as a minus b, parenthesis, a squared plus ab plus b squared. Then from here, I will apply the same thing to this one. So my y cube minus 1 can be written as y cube minus 1 cube, which is equal to y minus 1 in parenthesis, y minus 1 in parenthesis, that is y squared plus y times 1. We have y plus 1 squared, which is 1. So I substitute in this with this expression. So let's continue. What am I getting? The limit as y is approaching 1 of y multiplying y, that is minus 1, multiplying y squared plus y plus 1, all on y minus 1. What are we getting? This takes away this, so we end up with the limit as y approaches 1 of the expression y multiplying y squared plus y plus 1. So as y is approaching 1, what will our limit be? Our limit will be 1 multiplying 1 squared plus 1 plus 1. 1 plus 1 plus 1 is 3. So 3 times 1 gives us 3. This is so simple. It's very, very simple. You can also use the other method, the rationalization method. That one is also simple, but then it depends. You may need to rationalize twice because we have a set in both the numerator and the denominator. So rationalizing twice, what are you going to get? If I rationalize the numerator, so that one would be s squared plus root of x divided by s squared plus root of x. Then I rationalize the numerator. That is root of x plus 1 divided by root of x plus 1. So for the numerator, this can be written a difference of 2 squares. So I'll have the limit as x is approaching 1 of x, that is to the power 4, minus root of x all squared, and that will be x. Just as simple like that. Then I multiply this by the expression root of x plus 1. Let me write this well. That is x divided by, now this expression when multiplied by this expression would also be difference of 2 squared. So I have root of x all squared, which is x minus 1 squared, 1, multiplying x squared plus root x. Now from here, some of the terms can cancel out. So the limit as x approaching 1, I can factorize x out from here. What do I get? I get x cubed minus 1 multiplying root of x plus 1 all on, that is x minus 1 multiplying x squared multiplying, so multiplying, so multiplying x squared plus root of x. Now from here, what do? I can factorize this as difference of 2 cubes, and that will give me, I've already showed you, so I'm substituting in straight. So it will be x minus 1 x squared plus x plus 1 multiplying root of x plus 1 all over x minus 1 x squared plus root of x. So this cancels this. What do I end up with? I end up with, that is x multiplying x squared plus x plus 1 times root of x plus 1 all on x squared plus root of x. So let me check if I don't want to do any mistakes, so I'm checking thoroughly. Okay, let's continue. So now what would the answer be? So from here I can do a direct substitution. If I substitute in 1, what am I going to get? 1 plus 1 plus 1 is 3. Here becomes 2. Here becomes 2. 2 cancels 2. Then we end up with 3. So as x is approaching 1, 1 times 1 squared plus 1 plus 1. Root of 1 is 1 plus 1 divided by 1 plus 1. So I end up with, that is 3. So we are obtaining the same answer for that. You're obtaining the same answer for that. So I think I think it was cool. Now I want to introduce another form of an indeterminate. Let's say you have a limit, right? Then after perform the direct substitution, you end up with the form infinity minus infinity. Now, if you have such a form, what do you do? What do you do? Now, you try to change. You can change it from this form to infinity over infinity form. Or what do you do? That is, you change to 0 over 0 form. So whenever you have such a limit, what do? You try as much as possible to change it from, that is, the infinity minus infinity form to the infinity over infinity form, or the 0 over 0 form. And I'll give you an example. I'll show you a nice example. So if you have, say, if you have, say, the limit as x is approaching infinity of root of x squared plus 2x minus x. So if you have such a limit, you see, after performing your direct substitution, what do you end up with? You end up with, that is, the square root of infinity squared plus 2 times infinity minus infinity. All this gives infinity minus infinity. So you're ending up with infinity minus infinity term, right? This is the form you're ending up with. Then we can't really determine, that is, the actual value of our limit, because we have two infinities and we don't know which is greater than the other, right? So it is indeterminate. This is an indeterminate form. Then what do we do if you have such a form? As I said, you change it to, you change it to infinity over infinity form or 0 over 0 form. And how can you do that? That is, for this particular one, you can rationalize. So, rationalizing, I get limit as x approaches infinity of plus 2 minus x. I'm multiplying by the conjugate pair. So multiplying this by the conjugate pair, I end up with x squared plus 2x plus x divided by root of x squared plus 2x plus x. Now the job is done. So the limit as x is approaching infinity of, now this can be written at difference of two squares, so we end up with, that is, the root as x of x squared plus 2x all squared minus x squared all on, that is, root of x squared plus 2x plus x. What do I get? I get limit as x approaches infinity of x squared plus 2x minus x all on root of x squared plus 2x plus x. Now from here, the job is done. So limit as x approaches infinity of x squared minus x squared goes away. 2x on root of x squared plus 2x plus x. Here I can perform some algebraic manipulation here. I can apply my algebra skills, sorry, to the limit 2x. So I ended up with limit 2x of root of, let me check, 2x of root of x squared plus 2x plus x, root of x squared plus 2x plus x as x approaches infinity. That's actually simple. As I said, you factorize out a variable from here. You do same for this one. such that both variables in the numerator and the denominator will cancel out, and leaving behind expressions such that when x approaching infinity is substituted into it, you don't end up with an indeterminate form. So let us do that for this one. So the limit as x is approaching infinity, factorizing x out for the numerator. Now for the denominator, I can do one thing. Now for this, I can factorize out root 2 out, root x squared out, sorry. Now what do I have? 1 plus, that is 2 over x, because I'll divide this by what? I'll divide this by, what do we call it? I'll divide this by x. I want to rewrite it well. The square root of 1 plus 2 on x squared. Now, the second one is x. As simple as that. Now, this is absolute of x, but since we are dealing with a positive infinity, I can write this as x. Root of x squared is x. So x divided by, now since here is x and we have x here, they are common. So I can factorize it out, leaving behind root of 1 plus 2 over x squared plus 1. So this and this cancel out. Then I have limit as x approaches infinity of 1 over root of 1 plus 2 on x squared plus 1. So as x is approaching infinity, what do I get? I end up with root of 1 plus, that is 2 on infinity, plus 1. And as I said, that is, if you have a value divided by infinity, that whole value will approach 0. So I have 1 over 1 plus 0 plus 1. So I end up with 1 over 2. So the answer is half. Half. This is a simple one. That is one way of solving such a problem. You also have another way of solving such a same problem. As I said the last time, you can also substitute in some particular, y value, such that when that particular value is substituted in, you can eradicate the said expression, right? Or you can also substitute in, that is, x is equal to 1 over y. Can substitute in, so let me see method 2. Substitute in x is equal to 1 over y, then you also obtain the same answer. So we can do that. So x is equal to 1 over y. Our question was this, x squared plus 2x minus x. So let x be equal to 1 over y. Now if x is equal to 1 over y, then as x approaches infinity, our y will also approach 0. So the limit as y approaches 0 of, that is 1 over y squared plus 2 over y minus, that is 1 over y. Now the work is done. I will simplify what is under the root here. So what do I get? I end up with limit as y approaches 0 of root of, the LCM is y squared divides y squared one time, plus y divides y squared, that is y time. So you have 2y minus 1 over y. I can write this as the limit as y approaching 0. You see, I can write this expression as, that is the root of 1 plus 2y all on root of y squared. Now, so if I take the root of y squared, what do I get? Y. So I can write this as root of 1 plus 2y divided by y minus 1 over y. Then from here I can say the limit as y is approaching 0 of root of 1 plus 2y minus 1 divided by y. So from here, the job is done. From here, the job is done. What do you have to do? You can rationalize or substitute in some term such that that particular term will eradicate this radical expression. So that's what I'll be doing. So let's say a be equal to a squared, be equal to 1 plus 2y. You can also rationalize if you like. Yes, you rationalize or you substitute in a term that will eradicate this, the radical or the set. So the limit as y approaches 0 of, if a squared is substituted here, the root takes away the squared. So I can say a minus 1. Now what is y? Make y the subject from here. What are you going to get? You end up with a squared minus 1 all on 2. A squared minus 1 all on 2. We end up with the limit as y approaches 0 of, that is 2 multiply a minus 1 all on a squared minus 1 can be, that is factorized as a plus 1, a minus 1. This cancels this one. So as y approaches 0, what do we have? We have 2 divided by, that is, sorry, I forgot to change the limit. Now, if a squared is equal to 1 plus 2y, then as y is approaching 0, what will a be? That is, my a will approach 1. So a should approach 1. A should approach 1. So my a approaches 1. My a approaches 1. So as my a approaches 1, what am I going to end up with? I end up with, that is 1 plus 1. 2 on 2, and my answer is 1. That is so simple to understand. You can also try another problem as such. Let's try a last problem and then call it a day. Now, another problem is, say the limit as x approaches infinity of root of, that is x plus root x minus root of x minus root x. Now you're also going to obtain the same form. After doing your direct substitution, you get infinity minus infinity. So what do you do? You rationalize. So let's rationalize. So limit as y approaches infinity, you multiply both the numerator and the denominator by the conjugate pair. So the conjugate pair is root x plus root x plus root of x minus root x. Coming. Now, let's continue. Let me clean this off. Okay, so now I can write this as difference of two squares. Supposed to multiply the denominator by the same expression. Good. So for the numerator, this can be written as difference of two squares. So I can say that's the limit as y approaches infinity. Writing them as difference of two squares, what do I get? This squared will eradicate the z, leaving x plus root x. The same applies to here. What am I going to get? Negative x plus positive root x all over for here, what do I get? Root of x plus root x plus root of x minus root x. That is so simple. Now, what do we do next? The limit as y approaches infinity of x minus x goes to 0, end up with 2 root x divided by root of, let me rewrite it again, root of x plus root x plus root of x minus root x. Now, when we substitute in y approaching infinity into the expression, we end up getting, that is, infinity over infinity, an indeterminate. So what do? We try as much as possible to, that is, try as much as possible to, that is, manipulate our expression. We can either rationalize or do a normal manipulation such that some of these terms will cancel out. Then we can evaluate our limit such that we wouldn't get an indeterminate form. So what do I choose to do? Now I choose to rationalize the denominator. So we are rationalizing again. So rationalizing x plus root x minus, I'm multiplying both the numerator and denominator by the conjugate pair, divided by root of x plus root x, that is, minus root of x minus root x. Now, what do we obtain? So we cancel out. You realize that our denominator will cancel out. So let us do that. Our denominator will, but even if I don't rationalize, I think I can still simplify this. Let me do some manipulations here then. Okay, so from here, this is what I can do. Now, fine, you can choose to rationalize, that's no problem. Or I've wiped everything, no problem. Let me just start again. No problem. Now, as I said, the numerator can be written a difference of 2 squares to the limit. I just pressed on something and everything went. So let me rewrite everything again. The numerator I end up with, that is x. I mean, it was 2 root x, I guess, divided by root of x plus root x plus root of x minus root x. So now let me do one thing. So the limit as y is approaching infinity. Now for this term, I'll try and factorize out root x, sorry. Now, so I'll have root of, that is, x out. I'm coming. So it will be 2 root x all over, that is, for here. For this particular square root, I can factorize out x, then 1 plus, that is, root x over x. Then what am I going to get? Plus. I do the same for this one also, x out, 1 minus root x over x. Now, what can I do next? It is so simple. What can I do next? 2 root x. You realize that for here, I can separate the root x and separate this root x as, so I can write it as root x multiplying, that is root of 1 plus root x on x plus root x multiplying, that is root of 1 minus root x over x. I can factorize root x out to cancel out the root x here. So the limit as x approaches infinity, 2 root x cancelled, leaving behind root of 1 plus root x on x. Let me go this side. Okay. 1 plus root x on x plus root of 1 minus root x over x. Now, but then you realize this expression can be written as the root x over x can be written as what? That is x raised to the power half divided by x to the power 1. Can be written as half x raised to the power half minus 1, so x raised to the power negative half. So this can be written as, just take your time and do it. It is so simple. This can be written as x approaching infinity of, that is square root of 1 plus 1 over, cos 1 over, x raised to the power negative half is 1 over root x. The same applies to the other term as well, plus root 1 minus 1 over. So you realize as x is approaching infinity, this value will approach 0. This value will also approach 0. So what are we going to get? End up getting 1 over root 1 plus 0 plus root 1 minus 0. End up getting 1 over 2. That will be our answer. So yes, I'll end the class here. We'll meet in a different lecture and then also solve some problems on limits. We may probably talk about other forms of indeterminate and probably some standard limits. Have a wonderful evening.